right, so all of this talk of polymer chemistry, so I just talked a little bit about the history of nylon, and I also wanted to remind you all of the most abundant polymer. And again, a polymer is just a long string of molecules, repeating units. The most abundant polymer is cellulose, which is chains and chains of sugars that are linked together. All right? And that is actually related to this next kind of polymeric thing that we're going to be making. And that is that it uses cornstarch. Okay? So when you have anything that's starch in it, that is implying that it is, again, these long chains of sugars that are linked together. All right, so sometimes we just call those carbohydrates, but carbohydrate is a general term that would include sugars, like a simple sugar like glucose, or it could be a disaccharide, two sugars linked together, like galactose or sucrose. All right, so smaller sugars, or you could have longer chains to create a starch. Okay, and so specifically this starch, obviously, because it says right here on the label, this comes from corn. But you could have a starch, or in other words, long chains of sugars that comes from a potato or something else. Okay, but because I guess just in society we just started using cornstarch at some point, so that's a really common type of starch for someone to buy, to purchase. So, what is this used for? Well, it's a thickener. So if you didn't know that, some people might say, of course it's a thickener. And some people might say, cornstarch, what do you use that for? Okay, so depends on how much time you spend in the kitchen, right? So it's used as a thickener because it is, once again, same idea. We have these long chains, and when you have these long molecules, they are then interacting with each other, and it causes them to be very viscous. Okay? And so it's the same idea with this. So let's open this up, and let's put a little bit of cornstarch in our bowl. Oh, what do you know? It's brand new. I didn't even realize that. I had a brand new. Okay. Let's open this up. Okay, cornstarch. Reveal yourself. Okay. All right, so here's our cornstarch, and I don't know if I even really need to scoop it. I'm just gonna dump it right in here. Okay, I think that's probably enough. A little bit more. It's pretty tightly packed in there. Okay. So it's hard to tell right now that this is made of these long chain polymers because it is in this solid state. Okay. So all of our states of matter, they include the solid phase. We have the liquid phase we've been talking about with our glue. And there's the gas phase. and there's the aqueous phase. All right, and as we just live as humans, we learn to identify each of these phases by just noticing things like, if it's the solid phase, it keeps its shape, right? Like this bowl, solid phase, it keeps its shape. This paper here, solid phase, keeps its shape. This metal knife, solid phase. And same with the cornstarch right now. Okay, so it's pretty fluffy here, but overall it's keeping its shape. We can shake it around. Okay. So what about liquid? Let's think about liquid phase and how we could identify it. Again, this is one of those ideas where we know liquid so well, we don't even think about, why is it a liquid? What is it about water at room temperature that makes it a liquid? Why do we call it that? It pours? Okay, what else, right? So let's think about this. Here we have water, and it's in a container. Okay, why do I have this water in a container? Why isn't the water just like on my paper here on my table? If I just dumped the water on the table, it would go everywhere, right? Same reason why I have this lovely turmeric drink in a bottle. We need to contain it. So the way our liquids flow, those molecules are free flowing. They end up taking the shape of the container that they are in. But they do sink to the bottom, right? So you can have an open container that can hold your liquid. I really wish I was clever enough to think of an open container joke, but it's not coming to me right now. Okay. So, but this is water, right? Okay. So, with our liquids, we think about those sorts of properties that our liquids have. Free flowing, they take the shape of the container they're in, right? And with solids, they have a hardness to them, and they hold their shape. Okay, things like that. Just very quickly, let's just finish up this thought and talk about the phases of gases and of aqueous. So gases, they also take up the container they're in, but the container needs to be closed. So we actually did an experiment. Oh, I guess I have done an experiment in the last 2 weeks. I think it was just last week. We did an experiment where we had a gas inside of a bottle, and then we put the bottle in the freezer, and it collapsed on itself. Okay, it shrunk, it got smaller because of the pressure inside was staying the same, so the volume had to go down because the temperature was going down. So we were looking at gas laws, and we did that. Okay, so in that case, we had a closed container, and we were thinking about the gas that's inside of the bottle. Okay. Gases expand to take up all that space. And then we have aqueous phase, and that is where you have particles that are dissolved into water. Okay, but what I want to focus on right now is the solid phase and the liquid phase. So we're seeing solid phase for our cornstarch right now. We're seeing liquid phase for our water right here. And now what we are going to do is mix them together. Now, I'm only going to add a little bit because once again, just like when you're making slime, you don't want to add too much. Okay? So I'm looking for certain consistency. So, when you add cornstarch to gravy, you just add a little bit in there and you stir it and you see it gets a little thicker, and then maybe you add a little bit more. Okay. What we're doing here is we have a big lump of cornstarch and we added some water to it. Because my goal here is we're going to stir this together until the cornstarch and water have created what is known as a non-Newtonian fluid. And the reason why this is such an interesting material, I'll call it, is that it has some properties of liquids and some properties of solids. And it reacts to pressure in a very interesting way. Okay, so let's see how it's doing. I feel like I need to add a little bit more of the cornstarch. For our cornstarch water mixture to behave as a non-Newtonian fluid, it needs to have a certain ratio of the cornstarch to the water. Okay, we're getting closer. Yes, I can feel it. Okay, so right now we are to the point where I think it's going to be, that might have been too much. That's okay. This kind of reminds me of making a frosting. Have you ever made frosting? Powdered sugar and water, and sometimes it gets to this point where it's like too liquidy, and then you add a little bit more powdered sugar, and then it's too thick. Yeah. So that's what this is reminding me of. But we're so close. Okay. So if you have made Oobleck before, and honestly, I don't know, or perhaps I just don't remember if I did know once who made up the name. It's such a funny name. I like it. It reminds me of, in astronomy, I got the image. In astronomy, where they name a nebula some name that's like the E13216 or something, as opposed to the Lagoon Nebula. That's such a magical name, right? And so some of these chemical names can be just kind of boring. So I like it when they come up with creative names like Oobleck. So here we're beginning to see, and the challenge for me and you, the way we're doing this together right now, is for me to truly show you the differences in these two phases of matter. And so I will do my best and show you. Okay. And so this is what these PhD scientists found so fascinating about this mixture of cornstarch and water, is that if you look at it like this, okay, it's swirling around. This looks exactly like a liquid, right? Okay, so we've got this liquid, and really nothing that unusual about it. In fact, I could probably, if we started the live stream right now and you hadn't seen me create this, I could tell you, if I wanted to lie, I could tell you this was like glue. And you go, oh yeah, glue. Okay, liquid glue, no problem. Okay? You wouldn't question it just based on the observations that we're seeing. Okay? But this is then what baffled these scientists. Okay, let's see if I can get it here. I might need a spoon, actually. What has baffled these scientists with Oobleck is that if you, I'm going to pick this up. Okay, so if I grab it, I'm going to grab this with my hands. It looks like a liquid, but if I squeeze it, it is a solid. So right now, this feels like a solid to me. Okay, it's fairly hard. Okay, when I press it together, this is a solid. I can even squeeze it together. I could roll it into a ball. I can roll it into a ball, like a little piece of Play-Doh. Okay, so right now it looks like a little ball, a little hard ball. Okay, but as soon as I let go and I stop squeezing it, it turns into, are you going to do it for me, Oobleck? What this Oobleck begins to do is behaves like a liquid. So it essentially is, it's living in this realm that is between solid and liquid, depending on whether it has pressure adhered to it. So right now, it's dripping through my fingers. It's acting like a liquid. But as soon as I squeeze it, immediately it's a solid. Squeeze it, solid, let go, liquid. Squeeze it, solid, let go, liquid. So, because it is somewhere in between the two, it has baffled scientists exactly how does it do this. This is a very unusual property that compounds have, and what I find especially fascinating about this is that it is so simple to make. It is safe to make. It is non-toxic. As you just saw, we just take cornstarch and put in water. You could eat this if you wanted to. And but then at the same time, we are, like right now, I am playing with this chemical compound that is very baffling to scientists and has been for quite some time. So I just love that. I love the things that are simple yet complex. And